We're going to continue with the example from the last lecture. There are a couple of issues with this implementation. The first issue is that we can create a stream object and call the open method. Why is this an issue? Because this stream class is an abstract concept. What does it mean to open a stream? Are we working with a file stream here, a network stream? What kind of stream? So we shouldn't be able to directly create an instance of the stream class. We should always subclass it and then create an instance of the subclass. That is the first issue. So we only created this stream class as a base class to provide some code that we're going to reuse across different kinds of streams. This is the first issue. Now the second issue. If you look at the implementation of file stream and network stream classes, you can see both these classes have a read method. If tomorrow we decide to create a different kind of stream, we should remember to implement this read method and call it exactly read. If we call it readline or read str or read whatever, it's not going to be consistent with the other kinds of streams that we have here. In other words, currently there is no way to enforce a common interface across different kinds of streams. This is more of a convention we have used here. It would be nice to have a common contract or a common interface across these different types of streams. So how can we solve these problems? That's when we use an abstract base class. An abstract base class is like a half-baked cookie. It's not ready to be eaten. It's half-baked. It's half-cooked. Its purpose is to provide some common code to its derivatives. So here we want to make this stream class an abstract base class. To do that, we go on the top and from ABC module, which stands for abstract base class, we import the ABC class and abstract method function, which we're going to use as a decorator. So make sure to type this exactly like what you see here. So the name of the module is all lowercase and the name of the class is all uppercase. Now, to make this stream class abstract, we should derive it from the ABC class, abstract base class, okay? That is the first step. The second step is to define the common interface for all streams. We want all streams to have a read method and potentially a write method in the future. So here we define a read method. This method has no implementation. So we simply pass here. Now we need to decorate this method with abstract method decorator. With these two simple steps, we fix both the problems I talked about in this lecture. So now, if I save the changes and try to run the program, you can see we immediately have this red underline with abstract methods instantiated. Basically, when a class has an abstract method, it's considered an abstract class, and we cannot instantiate them, which means we cannot create an instance of them. So when we run this program, we get this type error, okay? Now let's look at the second problem. So let's say tomorrow we're going to create a new kind of stream. We call it memory stream, and we derive it from the stream class. For now, let's just pass and create a memory stream object. Once again, you can see we have a red underline, abstract class with abstract methods instantiated. What's going on here? In our stream class, we defined an abstract method called read. Let's take a look. Here's our abstract method. If a class derives from the stream class, it has to implement this method. Otherwise, that class will also be considered abstract. So in this example, our new class, memory stream, is also abstract. If we want to make this a concrete class so we can instantiate it, we'll have to implement the read method. So define read, and here we print reading data from a memory stream. Now, this memory stream is a concrete class. We can instantiate it here, and it also follows the contract or the interface of the stream class. So all our streams now have a read method.